so let's go ahead and go over our practice problems for the quiz. So for these first few, we're going to find the solutions over the interval 0 to 2 pi. And notice that it says find all the solutions. So anything within one full rotation, we want to include. And notice that 0 and 2 pi are the same point on the unit circle, but we would include 0 if that was our answer. We would not include 2 pi. So if that location comes out to be our answer, we say that it's 0, not 2 pi. We do not need to have both. Now if we take a look at number 1, we have 5 sine x minus 2 equals 3 sine x minus 1. Now remember, we're going to start this out just like algebra. So we want to get our trig function by itself. We only have one trig function, that's sine x, and it's not squared, it's a single sine x. So our goal then is to get that sine x on one side by itself and then equals whatever, and then go from there. So algebraically speaking, we would want to move this 3 sine x. So we would subtract it, and then we're going to subtract it from the other side as well. So then this is going to give us 2 sine x. We still have our minus 2. This is gone, and then it equals negative 1. So then the next thing we do to get sine by itself is we're going to go ahead and add this 2. And so this is going to give us our 2 sine x. Those are gone, and then it's going to equal 1. Then the last thing we do to get sine x by itself is to divide by 2. So then this gives us sine x all by itself equals 1/2. Okay, so algebraically, that's all we've done is algebra. We got sine x by itself. Once we have that by itself, then we go to our unit circle, and we want to decide for what angles on our unit circle sine would be 1/2. Well, we know sine is the y value. So if the y value is positive, that means it has to be in the first quadrant or the second quadrant. Now, since sine is the y value and sine is going to be 1/2, that means we're going to have 1/2 here, 1/2 here. And therefore, the reference angle would have to be 30, because across from 30 degrees is always 1/2. So if our reference angle in both of those quadrants is 30 degrees, then that means our answers have to be something over 6. So we're going to have two answers, both over 6. So in the first quadrant, that would just be pi over 6. In the second quadrant, that would be 5 pi over 6. Because since it's over 6, half a rotation would be 6 pi over 6. A full rotation would be 12 pi over 6. And since we're going not quite all the way halfway around, it is 5 pi over 6. So those would be our two answers for number 1. Now for number 2, we also only have one trig function. However, this time that trig function is squared. So we still want to get that trig function by itself. So we want to get cosine squared by itself. But since it's squared, that means once we do get it by itself, we're going to need to square root. So to get the cosine squared by itself, the first thing I would get rid of is that 4. So I add it to both sides, and this will give me 16 cosine squared x equals 4. Then I would divide by 16, and so then this would give me cosine squared x equals, and 4 over 16 simplifies, so I'm going to simplify that to 1/4. Now, since I have cosine squared by itself, that's great, but I still need to get cosine by itself. So that means I need to square root this, which means I also have to square root the other side as well. So on the left side, that gives me just cosine x. On the right side, if I take the square root of 1/4, well, the square root of 1 is 1, the square root of 4 is 2, but because I took the square root on both sides, I have to include plus or minus in front of my answer. So then when I go to the unit circle, I'm looking for where cosine could be either positive 1/2 or negative 1/2. Now, cosine is the x value. So if cosine is going to be positive, that means x is positive. That would have to be somewhere on the right side of the graph. So that could be the first or the fourth quadrant. If cosine is going to be negative, that means x is negative. That's going to be somewhere on the left side of the graph. So either the second or the third quadrants. So that means we are going to have 4 answers to this problem. Now, if the x value, cosine, is 1/2, then that's great, but remember, our reference angle is based on the y value. So if the x is 1/2, that means the y is square root of 3 over 2. And across from square root of 3 over 2 is always 60 degrees. So that means all of these angles are going to be 60 degrees. That means that my 4 answers that I'm going to get are all going to be over 3. So then I just need to figure out what those are. Well, in the first quadrant, this is just going to be pi over 3. In the second quadrant, that's going to be 2 pi over 3, because halfway around would be 3 pi over 3. That means that in the third quadrant, that's going to be 4 pi over 3. And then in the fourth quadrant, that's going to be 5 pi over 3, because the full rotation would be 6 pi over 3. So we have our 4 solutions. Now, for your solving, also remember that when you solve, you may have to do some factoring. So keep that in mind. Anything you would do in algebra to solve, you could also be doing here to solve. So you may have to factor and then set your factors equal to 0. So just keep that in mind. That is always a possibility. Now for number 3, we want to find the exact value of cosine 1/3 times cosine of pi over 3. Cosine of pi over 3 times cosine of pi over 12 plus sine of pi over 3 equals sine of pi over 12. Now, what we need to do for this is we need to remember that this is actually one of our formulas that we had for our sum or difference of angles. So when we've got our sum or difference formulas, we need to look at this and we need to compare it to the formulas that we have. So when we look at our formulas, we're looking for one that says cosine times cosine plus sine times sine. So if you look at your identity sheet, we can see that the only ones that say cosine times cosine and sine times sine, are the cosine formulas. So we then need to decide, is it a cosine of a difference or cosine of a sum? So because of this plus in the middle, that matches our formula for cosine of a difference. So our formula is cosine of alpha. I can't draw this today. So cosine of alpha, there we go, minus beta equals cosine of alpha times cosine of beta. Then we have plus sine of alpha times sine of beta. So that matches what we have here, which means that what we can do then is we can go ahead and work this formula backwards. So we know that according to what we have, this has to be my alpha, this has to be my beta. So this is alpha, this is beta. So I can go ahead and fill those in. I have cosine of alpha is pi over 3 minus beta, which is pi over 12. Now what we want to do is we want to go ahead and try to simplify this. So in order to go ahead and combine these fractions, they need a common denominator. Therefore, I want to go ahead and I'm going to multiply this by 4, which means the top gets multiplied by 4. So then this is going to become cosine of 4 pi over 12 minus pi over 12. Now that I have the same denominator, I can go ahead and combine those. So it's still cosine, but it's cosine of 4 pi over 12 minus pi over 12 would be 3 pi over 12. And then that fraction will simplify. So since 3 over 12 becomes 1 over 4, this fraction just becomes pi over 4. So then once we get it to that point, then we go to our unit circle and decide what is cosine of pi over 4. Well, pi over 4 is in the first quadrant, and because it's over 4, we know it has a 45-degree reference angle. Therefore, both sides are going to be square root of 2 over 2, and they're both going to remain positive in the first quadrant. Then, because we want cosine, that's the x value, and they do happen to be the same this time, but you do need to make sure that because it's cosine, you use the x value. So this simply becomes square root of 2 over 2, and that would be our answer. So what you have to be able to do on these is you've got to be able to recognize that what they've given us here matches one of the formulas that we have for the sum or difference formulas. Figure out which one it matches, and then basically you're working it backwards until you get it to a single angle, and then you can evaluate it on your unit circle. All right, then our last problem on our practice problems is to find the exact values of sine, cosine, and tangent of the angle using a sum or difference formula. So again, we want to have our sum or difference formulas in front of us on our formula sheet. And then we're basically going to treat this as 3 separate problems. So we're going to start by doing sine of 255. Now, we don't have 255 on the unit circle, which is why we have to do our sum or difference formula. Now remember, we said that in class that if it ends in a 5, then you want one of your angles to be 45 degrees. So then we just need to decide, well, 45 degrees plus what gives me 255? And so that would be 210. So 45 plus 210 is 255. So this is what I want to use. So I'm actually doing sine of 45 plus 210. All right, then we go to our formula. So our formula on our sheet tells us that we are going to do sine of the first angle, which is 45, times cosine of the second angle, which is 210. Then for a sum, we're going to do plus, and then we have cosine of the first angle, which is 45, times sine of the second angle, which is 210. Now we go to our unit circle and we start filling in values. So remember, this is going to become a fraction, this is going to become a fraction, this is going to become a fraction, and this is going to become a fraction. So the first fraction, sine 45. Well, 45 is an easy one. We know that 45-degree angles are always sides of square root of 2 over 2. So that means sine for this one would just be positive square root of 2 over 2. And it's positive because it's in the first quadrant. Now, for cosine 210, that's not one that we just automatically know. So let's draw that angle. So 210 is going to be in the third quadrant. So if we draw our third quadrant here, then since this is 180 and this is 210, that's a difference of 30 degrees. Therefore, across from 30 degrees is 1/2, and the other side then would be square root of 3 over 2. Now, we do have to remember, though, that because these are in the third quadrant, that means they are both going to be negative. So now, that means, remember, sine is y, cosine is x. So this would be cosine of 210, and this would be sine of 210. So first one I want is cosine of 210, so that is negative square root of 3 over 2. Then we have plus. Now we want cosine of 45. Well, 45 is always square root of 2 over 2. And then we want times sine of 210. Well, we said in our triangle, sine for 210 is negative 1/2. Once we have that, then it's just fraction math. We always have to multiply before we add, so we're going to go ahead and multiply those together. So we know that that's going to give us square root of 2 times negative square root of 3, so it is going to become negative, and then that will be the square root of 6, because 2 times 3 is 6. And then on the bottom, we have 2 times 2 is 4. Then plus, now we multiply these two together, so I have square root of 2 times negative 1. That means that's going to give me negative square root of 2. And then on the bottom, 2 times 2 is 4. And we should have the same number on the bottom, which means this answer will just come out to be negative square root of 6. And then instead of plus and negative, I'm just going to put minus square root of 2. And then all of that is over 4. So that would be sine of 255. All right, now next we want to do cosine of 255. So then for cosine, we're still using 45 plus 210. So we're going to do cosine of 45 plus 210, because we're still doing an angle of 255, so 45 plus 210 is 255. Then, according to our sheet, we've got cosine of a sum. So when we look at our formula, that's the second formula on our sheet. And that one tells us that we want to do cosine of the first angle times cosine of the second angle. And then we're going to have minus sine of the first angle times sine of the second angle. So remember, this will be a fraction, this will be a fraction, this will be a fraction, and this will be a fraction. So we're using the same values, just in a different order and a different sign in between. So cosine 45 we know is going to be square root of 2 over 2. Cosine of 210, according to our triangle up here, is negative square root of 3 over 2. Then we have minus. We've got sine of 45, so that's going to be square root of 2 over 2. And then we have sine of 210, which according to our triangle is negative 1/2. So then, when we multiply, well, we know that both of these products are going to be over 4. So we could go ahead and make our life a little bit simpler and say, okay, well, I know this is going to become one fraction over 4. Now, for my first product, I've got the square root of 2 times negative square root of 3, so that is negative square root of 6. Then we have minus, and then for my second product, I have square root of 2 times negative square root of 1, which would be a negative square root of 2. However, I'm subtracting that. So if I subtract a negative, that's going to become plus square root of 2. And so then that would be our final answer. Then the last thing that we have to do is our tangent. Now, for the tangent, we're going to use the same combination. We're still doing 255, which is going to be 45 plus 210. So then, for tangent of 45 plus 210, this is the one that can get a little bit yucky. So we're doing tangent of a sum. So when we look at our two tangent formulas, this is going to be the first one. And that one tells us we're going to have our fraction. On the top, we're going to do tangent of the first angle, which is 45, plus tangent of the second angle, which is 210. Then on the bottom, we're going to have 1 minus tangent of the first angle times tangent of the second angle. Now remember that this is going to become a single value, this will be a single value, this will be a single value, this will be a single value. So sometimes they're fractions, and sometimes for tangent it can end up just being a whole number, such as tangent of 45 degrees. So because 45 degrees is in the first quadrant and 45 degrees always has the same side for x and y, that means that if you do tangent, which is y over x, you're going to end up with just 1. So that's a nice easy one to remember. Tangent 45 is always just 1. So that means on top we're going to have 1, and then we're going to have plus. Now we have to figure out tangent of 210. So let's go back up here to the triangle we drew a minute ago. And if we're going to do tangent, which is y over x, when we look at our two side lengths, they're both over 2, so we can go ahead and get rid of those 2's. They're going to cancel anyway. So then my y value is -1. My x value is negative square root of 3. So first thing I notice is a negative over a negative is going to be positive, so those are basically going to cancel. And then I also notice that I have a radical on the bottom, therefore I'm going to have to rationalize this. So it will become a positive square root of 3 over 3. So anywhere I see tangent 210, I'm going to put square root of 3 over 3. So we go down here, we've got our 1 plus, then tangent 210 is square root of 3 over 3. Then on the bottom, we have 1 minus, and then we have our tangent 45, which is 1, times tangent 210, which is square root of 3 over 3. Okay, so we're going to simplify this just a little bit. We know according to order of operations, we can't add or subtract until after we've done our multiplying. So the first thing we want to do is this right here. So the top, I'm going to leave exactly the way it is, at least for the moment. Then the bottom, I'm going to leave that 1 in front, but then I have negative or minus 1 times square root of 3 over 3, which is just going to be minus square root of 3 over 3. Now you have to be careful, because if either one of these had been negative, then that would have become plus. So if that had been a -1, it would have been plus square root of 3 over 3. If this had been a negative, then it would have been plus square root of 3 over 3. So be careful with your signs. In this case, they were both positive, so it remained minus. Now what we want to do is we have to try to simplify this. So the first thing that I want to do personally is get rid of those fractions. So since I have a 3 on the bottom of both of these fractions, then what I'm going to do is I'm going to multiply everything in this fraction by 3. So I'm going to take this entire thing, multiply it by 3, this entire thing, and multiply it by 3. So that's going to give me 3 times 1 is 3, and then 3 times this fraction, since the fraction has a 3 on bottom, those 3's are going to cancel, and I'm just going to get plus the square root of 3. On the bottom, the same thing's going to happen. I have 3 times 1 is 3, but then I have minus, and then 3 times square root of 3 over 3, the 3's will cancel, and I'll just have square root of 3. Now, do not be tempted to try to simplify at this point. You cannot cancel 3's. You cannot cancel square root of 3's, because this is a sum and a difference. You cannot cancel single terms. What we have to do is we have to multiply by the conjugate to get rid of that radical in the bottom. So we're going to take the denominator and multiply by the conjugate. So we know that it's going to remain 3 and square root of 3. But because the bottom is minus, that means our conjugate needs to be plus. So we're going to multiply by 3 plus the square root of 3 on top and bottom. Now, this gets a little bit ugly before it gets better. So when we multiply out on the top, we have 3 times 3 is 9. Then we have 3 times square root of 3, so plus 3 square root of 3. Done with this. Then we need to distribute the square root of 3. So we have positive square root of 3 times 3, that's positive 3 square root of 3. Then we have positive square root of 3 times positive square root of 3 is a positive 3, because it would be square root of 9, which comes out to just be 3. Then on the bottom, we're going to multiply that the same way, except on the bottom, since those are conjugates, the middle terms should cancel. So we have 3 times 3 is 9. then we have 3 times square root of 3, which is a positive 3 square root of 3. So we're done with this 3. Now we want to distribute our negative square root of 3. So negative square root of 3 times 3 is a negative 3 square root of 3. And then negative square root of 3 times positive square root of 3 is a negative. And remember, square root of 3 times square root of 3 would be square root of 9, which is just 3. Now, like we said on the bottom, these middle terms are going to cancel because they are identical except for the sign, so those are gone, which means the bottom of that fraction just becomes 9 minus 3, which would just be 6, but we'll come back to that. On the top, those middle terms do not cancel, they combine. So we can go ahead and combine the constants. So we've got 9 plus 3 gives us 12. And then we also have the 3's in front of the square root of 3 that we can cancel. So 3 plus 3 is 6, so that gives us 6 square root of 3. So then, because we have 12 plus 6 square root of 3, and then the bottom of that, 9 minus 3 is just 6, now we need to simplify. So if we look at the numbers that we have in front of, or all the whole numbers, we've got 12, we have 6, and we have 6. All of those can be divided by 6. Therefore, if we've got 12 divided by 6, that becomes 2, plus 6 divided by 6 is 1, so that's just the square root of 3. And then this 6 divided by 6 is 1, which we don't need to put that on the bottom. We can just leave it like this. So that would be our final answer. So tangent is definitely the longest and most complicated of the 3, but go slowly. Make sure you simplify, and you should be fine. So we're going to take the quiz now. If you have done your homework and checked your answers, then you should be fine on the quiz. So hopefully you've done that. But just remember, use your algebra, use your fraction math, and follow the things that you know. All right, good luck.